In this video, you learn about implicit differentiation. So far, you have differentiated functions in the form where y is written in terms of x only. Now, this form of the function is called explicit. But there are times that you cannot write y in terms of x only, such as in the function x cubed plus y cubed equals xy. Now, no matter how hard you try in this function, you will not be able to write y in terms of x only. So this is a function in its implicit form. When you want to differentiate function in its implicit form, you use the same set of formulas, but you have to remember that when you're differentiating, you're just differentiating with respect to a single variable. Say, for example, in this function, we want to get y prime. So it means to say when we want y prime, we will be differentiating with respect to x because y prime is the same as dy over dx, or the derivative of y with respect to x. So we have to differentiate each of these terms, each of these expressions, with respect to x. Remember that when we differentiate x with respect to x, we get 1. But when we differentiate y with respect to x, we only get dy over dx, or it's the same as y prime. So whenever we differentiate y with respect to x, we'll always get y prime. So in this function, differentiating x cubed with respect to x, we get 3x squared. Okay, plus the derivative of y cubed with respect to x, we will get 3y squared using power rule also. But then, in the power rule, remember, the derivative of u to the n is equal to n u to the n minus 1 times du, where du here is the derivative of the base. So in y cubed, the derivative of the base is the derivative of y with respect to x, denoted by y prime. Okay? Now, that is equal to the derivative of x times y with respect to x. Using the product rule, it's x times the derivative of y with respect to x, denoted by y prime, plus y, this is the second factor, times the derivative of x with respect to x, which is 1. Okay, now we just have to solve for y prime. So we have to combine all the terms with y prime on one side of the equation and then all the terms without y prime on the other side. So this will be transposed to the right and this will be transposed to the left. So we'll have 3y squared y prime minus xy prime equals the term y on the right side minus 3x squared. Now to solve for y prime, we have to factor out y prime from both terms on the left side. So we'll have y prime times the quantity 3y squared minus x equals y minus 3x squared. Now to solve for y prime, we have to divide both sides of the equation by the expression inside the grouping symbol, and that is 3y squared minus x. On the right side also, we divide by 3y squared minus x. So on the left side, we'll have to cancel this out. And now we'll have the final answer. That's y prime equals y minus 3x squared over 3y squared minus x. Now this is the derivative of the function, and this process is called implicit differentiation. Now there are cases wherein you can still write y in terms of x, but we will not choose to do that anymore. So instead, we'll just accept this function in its implicit form and differentiate each term on the left side and on the right side with respect to x, because we are looking for y prime here. Okay, so we have to differentiate square root of x plus square root of y equals 1 with respect to x. So we can write square root of x as x raised to 1/2, and square root of y as y raised to 1/2 equals 1. Now, differentiating both sides of the function with respect to x, you'll get on the first term on the left side 1/2 x raised to negative 1/2 plus, that's y 1/2 times y raised to negative 1/2. Now, don't forget the derivative of the base of the power of y raised to 1/2, which is y prime. So that's the derivative of y with respect to x equals the derivative of the constant 0. Now we'll just have to solve for y prime. Simplifying the first term, we'll have 1 over 2 x raised to 1/2, or that is square root of x, plus 1 over 2 square root of y times y prime equals 0. Now transposing all the terms without y prime on the right side of the equation, we'll have 1/2, or just y prime over 2 over square root of y equals negative of 1 over 2 over times square root of x. Then we'll just have to multiply both sides of the equation by 2 square root of y. So that we'll be able to cancel this out and just get y prime equals, that's a negative square root of y over square root of x. Of course, we have to divide 2 by itself here on the right side. So we'll just get negative square root of y over square root of x. This is the derivative of the function. Another example, x plus y times x minus y equals 7. So you have two options here. You may remove the grouping symbols first on the left side of the equation, or we may use the product rule to differentiate, okay, right away. So in this case, I'll choose to differentiate before simplifying. So let u, so this is a product of u and v, where u is the first factor and v is the second factor on the left side of the function. So differentiating using the product rule, you'll have u x plus y times dv. dv is the derivative of x minus y with respect to x. So the derivative of x with respect to x is 1, while the derivative of y with respect to x is denoted by y prime. Okay, plus v x minus y times du, where du is the derivative of x plus y with respect to x. So that is 1 plus y prime equals the derivative of 7, which is 0. Okay, so now we remove the grouping symbols and then solve for y prime. So for this term, removing the grouping symbols, we'll have x, so using FOIL method only, minus xy prime plus y minus y prime. Now for the second term, using FOIL method again, you'll have x plus xy prime minus y minus y prime equals 0. And then combine like terms. We'll have 2x combining x and x, we'll have 2x. And then combining negative xy prime plus xy prime, we'll have 0 combining these two. And then y minus y will also give us a 0. And then negative y prime minus y prime will get 2 or minus 2 y prime equals 0. Now we can just transpose negative 2y prime on the other side so that it will become positive, and we'll get 2x equals positive 2y prime. Alright, and then solving for y prime, just divide both sides of the equation by 2y. So this will be cancelled, and we'll get our final answer. And so it's 2 on the left side of the equation, and we'll get our final answer from there. Y prime equals x over y. This is the derivative of the function. Implicit differentiation may also involve trigonometric functions. So in example number 3, I'll give you a trigonometric function y equals sine of x plus y. Okay, taking the derivative with respect to y on the left side and right side of the equation, we'll have the derivative of y on the left side with respect to x, denoted by y prime. Now the derivative of sine function, the derivative of sine u, if you'll recall, is equal to cosine u du. So I have written the formula. So this is in the form sine of u. This is u. Okay, so the derivative of that would be cosine of u, x plus y, times du, where du is the derivative of x plus y with respect to x. So that is 1 plus y prime. The derivative of x is 1, plus the derivative of y with respect to x is denoted by y prime. Okay, so now we'll simplify. We'll remove the grouping symbols on the right side by distributing cosine of xy inside 1 plus y prime. So we distribute this inside, and we'll get y prime equals cosine of x plus y. Take note that x plus y is the angle of the cosine function, plus y prime times cosine of x plus y. Now, combining like terms or combining terms with y prime, we'll have to transpose this to the left side. So y prime minus y prime times cosine x plus y equals cosine of x plus y. And then again, factor out y prime from both terms on the left side of the equation. We'll get y prime times the quantity 1 minus cosine of x plus y. And this is equal to cosine of x plus y. So to solve for y prime, we simply divide both sides of the equation by the expression inside the grouping symbol, which is 1 minus cosine x plus y. Okay, do that same thing on the right side of the equation. So this will be cancelled out. And we get y prime equals cosine of x plus y over 1 minus cosine of x plus y. This is the derivative of the function. Another example involving trigonometric functions, sine of x plus y plus sine of x minus y equals 1. Okay, so we have to find y prime again. So we differentiate both sides of the equation with respect to x. Okay, the derivative of sine of x plus y with respect to x is cosine of x plus y times the derivative of x plus y with respect to x, and that is 1 plus y prime, plus the derivative of sine of x minus y with respect to x, and that is cosine of x minus y times the derivative of x minus y with respect to x, and that is 1 minus y prime, equals the derivative of the right side, which is 0. Again, we'll have to remove the grouping symbols and then solve for y prime. Removing the grouping symbols, we just have to distribute cosine of x plus y inside the parentheses, and also cosine x minus y inside 1 minus y prime. Okay, that's what we're going to do. So we'll have cosine of x plus y prime cosine of x plus y plus cosine of x minus y prime cosine of x minus y equals 0. And then we'll transpose these two terms to the right because they don't contain y prime. So y prime cosine of x plus y minus y prime cosine of x minus y will remain on the left side. And then the other two terms will have negative cosine of x plus y minus cosine of x minus y. Okay, and then again, factor out y prime from both terms on the left side of the equation, and we'll have y prime times the quantity cosine of x plus y minus cosine of x minus y equals, we can factor out negative 1 from both terms on the right side, so we'll just have negative of cosine of x plus y plus cosine of x minus y. Okay, so to solve for y prime, we divide both sides of the equation by cosine of x plus y minus cosine of x minus y. Do the same thing on the right side. Divide by cosine of x plus y minus cosine of x minus y. So this is equal to 1. And we'll get y prime equals negative of cosine of x plus y plus cosine of x minus y over cosine of x plus y minus cosine of x minus y. Now, this is the derivative of the function. Now, implicit differentiation may also involve higher differentiation. Say you're given x cubed plus y cubed equals a cubed. Find not just y prime, but y double prime. Okay, so still we differentiate both sides of the equation with respect to x. We get y prime first, and then we'll obtain y double prime from there. Okay, so we get y prime. On the left side, we'll have 3x squared plus the derivative of y cubed with respect to x is 3y squared y prime. We are getting the derivative of y with respect to x, so a here is just a constant. So the derivative of a cubed, since it is a constant, is just 0. Okay? You can solve for y prime, y double prime right away, or you may solve for y prime first. Y prime, upon transposing 3x squared to the right, you'll have 3y squared y prime equals negative 3x squared. So dividing both sides by 3y squared, okay, you can cancel this out, and then we'll get y prime equals negative of x squared over y squared. Now from here, we get y double prime. When we differentiate this function with respect to x again, on the left side, we'll get y double prime. Okay, left side y double prime. On the right side, we need to use the quotient rule. So just set aside negative 1 and then use quotient rule to differentiate x squared over y squared with respect to x. So in this case, this is u and this is v in our quotient rule. So that's y squared times the derivative of u with respect to x minus u times the derivative of y squared with respect to x. So that's 2y y prime. So in implicit differentiation, whenever you differentiate a power of y, you'll always get y prime. So whenever you differentiate an expression involving y, you'll always get y prime. So all over y squared squared, or that's y to the fourth. Now let's simplify our answer, and then remember that y prime is equal to negative x squared over y squared. So instead of writing y prime, we'll write negative x squared over y squared for it. Okay? Remember, the derivative must always just contain the independent and dependent variables x and y. So it must not contain y prime. If you can do that. Okay? So in this case, it's y double prime equals negative of 2xy squared. I just rearrange the factors. Minus 2x squared y prime over y to the fourth. Now writing for this one, for this expression, we'll write negative x squared over y squared because of this. Okay? So we'll have y double prime equals the negative of 2xy squared minus 2x squared y times y prime, which is negative equal to negative x squared over y squared. This is all over y to the fourth. Now we'll simplify because this is a complex fraction. We'll take the LCD in the numerator, which is just y squared, and we'll have y double prime equals the negative of, so we'll have y to the fourth still in the denominator. So LCD in the numerator is y squared. So we'll have in the first term, we'll have 2xy to the fourth. And then in the second term, we'll have plus already because of minus 2x squared y times negative x squared. So we'll have plus 2x to the fourth y. All right. So both y squared and y to the fourth will go to the denominator. And we'll have y double prime equals the negative of 2xy to the fourth plus 2x to the fourth y over y to the sixth. Okay, now there's a common factor between the two terms in the numerator, and that is 2xy. Okay, factoring 2xy from the numerator, we'll have y cubed plus x cubed. So y cubed in the first term, x cubed in the second term. This is still over y to the sixth. Look at the given function. In the given function, here, we have x cubed plus y cubed equals a cubed. And this is also x cubed plus y cubed. So this part is equal to a cubed also. Alright? So we can write the answer as negative of 2xy times a cubed over y to the sixth. We can still simplify by dividing y by y to the sixth. So we'll have y to the fifth in the denominator. And our final answer for y double prime is negative 2 a cubed x over y to the fifth. This is the second derivative of the function.